Good morning. WVGA notice. All right, I dug out my meter, my analog meter for the, I don't know why I'm shouting. I dug out my analog meter right here. You remember this power supply that I was going to build? It has a 0 to 100 full scale numbering on the meter. It was originally some sort of a power supply or something that they threw out at work many years ago, and it was made in England. It came with the Variac here, and I had used it with a bug zapper transformer which puts out 4,000 volts, and this is the one where I was going to make the voltage double and make it 8,000 for testing, you know, when you're trying to put voltages in to find out why an oscilloscope won't give a display or something. But I really don't need to do that. I could probably use this for something else, or maybe just using it as a 4,000 volt power supply. You don't really need a real high voltage power supply because I got the telemic and everything else that will work for that. What I want to do is take the 100 meg resistor and put it in series with the meter, which is what it originally had in here that I put in years ago, but I made up the 100 meg ohm resistor out of 10 megs. And I'm able to read 2,000 volts and 4,000 volts, but they're really down low on the scale. So I would really need like a 50 meg resistor, which I don't have, and I have to make it up, in order to give me maybe 5,000 volts full scale, and then I'll be able to read the voltage that way. But I want to demonstrate this on this video now, so let's get started. Okay, everyone, let's get my chair over here. Okay, you're probably wondering what that funny looking thing is right here. Alright, now this is a continuation of the mini, what the heck did I call it? Mini snapper, okay? It's a continuation of that and a kind of a combination of the high voltage probe saga, which I'm still struggling with, but I'm not really, I shouldn't say I'm struggling, I'm not really doing all that much with it. But I pretty much gave up on the digital meter type of high voltage probe, but I will be doing, I will take some suggestions. One of my viewers said they used a 100 meg resistor like I've got, and a 1.9 meg shunt resistor. I think I threw that drawing out that I had here that was across the meter leads. I may try that, but I cannot use an auto-ranging meter on that. Another one of my viewers emailed me, and I think his name was, yeah, Andrew. I don't know what his screen name is, but I guess I talked to him before because he's got my email address, and he was very helpful, but it's a very complicated formula that he did the math equations on in order to figure it out. But he also said something about not to change the ranges on the digital meter or something that could damage the meter. But my meter, my Fluke 73, is auto-ranging, so it will change the ranges anyways. So we pretty much gave up on digital meters, and we're going to use this. I think you could probably see that. I don't need to be on macro. I'm going to look at the full scale of this. I'm pretty sure it's 100 microamps full scale. And this was made this way, except for this. This was some sort of a power supply or monitor or something. It came with the fuse, it came with the meter, It came with the Variac and the switch. These were all in here, and the pilot light. It's awful hard to get you in camera here. And it's made by Research Instruments Limited, Kennick Road, Penryn, Cromwell, England. Okay, anyways, and this is the one, if you remember in my videos, I was cleaning up the panel and everything, and I was going to build a power supply, but it's got a lot of extra holes in here, and I never got around to it. And I think what will be better is to make a dedicated analog 5,000 volt full scale. Now, high voltage probe. If I elect to use this as a 10,000 volt full scale high voltage probe, I think I may be struggling trying to read down at the lower. Let me get you on the macro. Hang on a minute. I think I would be struggling down here. If you got 10,000 up here and you're trying to read 2,000 or 3,000 volts like you would be from these bug whackers, be struggling to read down here. In order to make this a 5,000 volt full scale instead of 10,000, well, the numbers don't jibe with that. I could make it a 1,000 volt full scale, but that's not going to do me any good. If I'm going to do that, I might as well use my digital meter and direct with the probes. So, short of changing the numbers on the bezel, I don't know of any other way to do it. So what I think my simplest answer to this would be to put the 100 megohm resistor in series, which I did have on this meter originally. And I want to show you the resistor I made up years ago. This was back when I had my shop in the attic. So you're talking, I would say almost 20 years ago when I did it. And this rheostat simply was in series with the primary of the high voltage bug whacker transformer and reduced the voltage. So I was able to get high voltage variations, but never down to zero, of course. But I could vary it between, I believe it was 2,000 to 4,000, if memory serves me correct. Here is the bug whacker transformer that was in one of them hanging bug whackers that you plug in and hang outside of your house or on a tree or whatever. And I took it and put it into this box. The rest of the case is put away right now. And used this meter to monitor the output voltage. I had removed all the stuff. I took the high voltage diode and capacitor out of the bug whacker, put it on this terminal strip. Now this terminal strip isn't really what you call a high voltage terminal strip, but at 4,000 volts it held up okay. And I had a high voltage lead coming out, and it was just an experimental high voltage power supply that I made. Nothing special. I figured I'd utilize the bug whacker because the bulb burnt out in the bug whacker anyways, and I had it for many, many, many years. So I save everything. I don't throw anything away if it's working. So, anyways, that's not what this video is about. I just wanted to show you the meter, and I'm going to give you the full scale. I got to read it off the meter. I want to give you the full scale readings. Hang on a minute. Okay, I looked at the meter and there is no markings on the meter, but if you look closely, where I left the DC on here, and if you look, I'm going to move this around so you can see. If you look real close, it'll say microamperes. Okay? So this meter is 100 microamperes full scale. Okay? So, when I put a 100 megohm resistor in series with this meter and put the high voltage across it, I could read 10,000 volts full scale. I have never tried putting 10,000 volts on it because at the time I built this, I had a 30,000 volt Pomona probe similar to the one I showed on one of my videos very recently. So this is 100 microamperes is the full scale right there. And the writing is crossed off with a black magic marker years ago. And I left the DC on there. So I'm going to put a 100 megohm resistor in this. And then I want to go into the high voltage power supply that I pulled out of the Harbor Freight bug zapper. You're wondering what this is. All right, let me give you, and you know what this is. This is the power supply out of the Harbor Freight, the second one. And I tinned the wires and marked them because these were two white wires, and I marked them so I make sure I don't reverse polarity. All right. Now, this works very well. This is a little different than the one that I had showed in the first video where I removed the capacitor. This capacitor here is not marked at all. No markings on it at all. I checked with my microscope iLope, the lighted one. It's a little different in that it don't have the extra holes in the board to add the second diode for voltage doubler and the second capacitor needed for the voltage doubler. So theoretically, I guess I can add it on the back. However, I may not need it. I may not need to double this voltage, and I'm going to tell you why. Let me get my chair and sit my ugly ass down at the bench. Hunch over the bench too much and my back will start bothering me. You're wondering what this is? It looks like an electric razor, doesn't it? Well, my son's electric razor, the blades went bad and they jammed up on him. I don't throw anything away. I first tossed this out in the recycle bin, and I says, wait a minute. What the hell's the matter with you, you old goat? There's probably usable parts in this thing. So there was an outer shell where the actual razor was in. I think this is a Remington. I'm not positive. But it came with a charger, which I saved. And it charges in here. Okay? So the outer shell is the actual razor. It had the buttons on it and everything else. So I took the screws out and removed the motor that was here. The motor was an awful hard job getting out, but I got it out. I stuck it in my little box where I collect my little motors for experiments and stuff, which I don't do too much anymore. In here, I can't even talk here. 3.7 volt rechargeable battery right here. Okay? I saved this part because this has got this little jack on the back here. I guess you can see that. I'm not on macro, it shouldn't be. I'm a good 18 inches away from the razor here. So this plugs in, this recharges through this circuitry. And here you got, I marked it red here because there's two black wires. This is the plus and this is the minus. 3.7 volts. Right now it's putting out 3.8 something volts. I powered this thing, which normally, as you know, takes two AA's, which is 3 volts, fully charged batteries, you know, new batteries, 3 volts. And I put the proper polarity on here, and I got almost twice the voltage out of this thing. It's really snapped loud, just arcing this over. So I don't think I need to bother with a voltage doubler, because I can use this. That's my intention, to use this. Now, there's a couple of things that you have to remember on this. You push this button. This would normally turn on your electric razor when you're shaving, okay? So in other words, this is going to be on. This is 3.7 volts or thereabouts when you're using it. So it can run the motor. It's sure as hell going to run this for a good long time. As a matter of fact, it could cook the transistor because it's designed for 3 volts. We're putting in almost a volt more. Not quite. But I don't think it'll hurt it. Some have suggested using 9 volts. Well, yeah, for a very short time it'll probably work until the transistor cooks. And it's an odd number on the transistor. So I'm going to try to improvise this circuit board here along with this here in one short handle. The only problem is if I put them back to back, insulated of course, it's going to be a very fat handle. Or in series, it's going to be fairly long. Alright? The problem is, this button here, you push it on, it stays on as long as you leave it like that. You push it again, it's off. When you want to charge it, let me see if I can get that in there. Okay, now hang on a minute, I gotta stop the camera a minute. Okay, supposedly it's charging. Okay, so this whole thing is a charging circuit as well as an on and off. Now I can eliminate this here and I'll just use this battery only, which is fine. It's 3.7 volts, but it's rechargeable. Then I'd have to take the bug zapper apart, you know, open it up, pull the battery out, and find a way to charge this battery, because it's designed to be charged on this circuit here, and these are soldered in. The battery's soldered in here. And they're usually stainless steel, and you're virtually impossible to solder to. They're usually spot welded. So, I would like to be able to use this whole circuit, but in order to do that, well, I better leave this on because obviously it needs charging. I guess it blinks as long as it's charging. As far as I know, the blinking means it's charging. Either that or something went wrong with the battery. Let me just turn this on and off. Let's see what it does here. Yeah, normally now you'd be using your razor and the lights would be on and you'd be shaving and the voltage would be coming out here to run the motor. Okay? Out of these leads here. Then when you shut the razor off, okay, well now it's a steady light. Okay. Alright, so I would say it's charging now. I would like to be able to eliminate this case here. I would like to be able to cut this jack off and leave it connected to the board, which it seems to be spot welded to the contacts, the pins. So in other words, I'd have to take the end of this plastic, this gray plastic, and try to salvage it so I can use this charger and make a rechargeable bug zapper. So I don't need this here anymore. I just kept this in the event that I was going to build something in this and cut this head off and put the grids on here, but that's not going to work out because you still need the high voltage power supply, so this is going to be too short. So what I need to do is to build this and this into the handle. I can go side by side like this, insulated of course so they don't touch, put a piece of plastic between them, and it'll be a flat, wide handle, maybe flat. Or, as I said, longer this way. That's in the planning stages, and what's holding me up is trying to find something to build it into that's going to be strong. I can't use a medicine bottle because the plastic is too brittle, it cracks. And trying to put this jack, super gluing it, or I don't have any epoxy right now, or hot glue, probably wouldn't be strong enough and it'll probably break the plastic. I need a plastic like this. I guess this is what they call ABS. So that's what I'm up against right now. So it's going to be a while before I do this. Right now, I'm trying to design something with materials that I have on hand now. We'll get back to I want to show you how much high voltage comes out of that. Running this on there, and then this video's long. That's why I record in WBGA.
That's why I record in WBGA.
This is the resistor arrangement that I made back many years ago, probably in the 90s, I'm going to say. 100 meg, there's 10 meg ohm resistors in series. I showed this, I know I did. There's the eyelet that went, where are we here? Eyelet that went to the meter on the back, the positive side of the back of the meter movement. And then I decided to get this 1% 100 meg ohm ready-made resistor off of eBay. No idea how many watts it is, but it's low current. My guess is it's not going to matter unless you short it out. You know, when you're, if you're arcing too much, maybe it might overheat the resistor. But you're measuring, I'm going to be using this as a way of reading high voltage using that analog meter that I just showed you. So we're going to put this in there instead of this one. Now if I want to read 5,000 volts full scale, my guess is I can just fold this in half and parallel them. Or I can make up another string, but back then I had excellent eyesight and able to do nice, neat work. Much better than I can do now. So it would be a little sloppy, but I could probably do it, but it'll have a lot of sharp points on it. I can probably stick it in a heat shrink or something, which is what this was originally. This was in a piece of heat shrink tubing, loosely in there, and no problem at all, but I was only reading 4,000 volts. Now it's a little awkward because I don't know how to do picture-in-picture, so you're going to have to take my word for it. When I put this power on here, I'm going to zoom in on the meter. Zoom, I know it's digital zoom. Let me see now. How can I zoom this? No, I can't. This is the, oh. Not sure how to do that. Because I got to keep touching it. I never use this feature on the Play Touch. Alright. Sorry about that. Tripod's a little stiff here. I can't help it. If I loosen it, then it'll be wobbling all over the place. Okay. I'm going to turn this on, but I can't read the scale on this. Let me turn this on here. See. I can't really tell. If it's 10,000 volts, 1,000, well, 20 should be 2,000 volts, so obviously I'm not. The output, by the way, it holds a charge. It's got a resistor across it, but it still holds a nasty charge. The output's reversed. In other words, this yellow wire here is supposed to be the outer grid, but it don't matter as long as there's no potential between the outer grid on one side and the outer grid on the other. It's not going to matter. But they just got it reversed here. So this is negative and this is positive. So that's why I got it this way, because otherwise the meter goes to the left and it's off scale. So I'm at a dilemma here. I thought I was able to read. The problem is on this meter. Let me get you off of this zooming thing here. I'm not sure how to use this stuff. I don't like this touchscreen stuff at all. Hmm. 100 microamperes full scale. That's according to what's on the meter bezel on the outside, as I showed you. I have my voltage turned off right now. I don't know why. If I'm reading, I got to read at least 2,000 volts on this with the 3.8 volts. There's 3.8 volts coming out of this. I measured it last night. Going in to the bug whacker. So it's a 3.7 volt battery, but you know, you're going to get a fraction of a volt more than that when it's fully charged. I'm running through the 100 megohm resistor in series with this 100 microampere full scale meter, and I don't even think I'm in camera. Oh, more time trying to get the camera angles right. I try to do good videos and I just can't seem to do them. I can work much faster if I was doing this off video, off camera. Okay, I don't know what's going on with this. I really don't. I thought I was going to be able to make an analog high voltage meter on this. But why is this reading? Let me see if I can get you a good close-up of this here. What I'm going to have to do is, I don't have the money now, and I probably never will. Go on eBay and get a damn 5,000 volt high voltage probe ready made up, you know, so that I can measure things like this. Because the VTVM will only read 1,500 volts full scale. I'm not going to put my VTVM on this and damage it. I don't have a high voltage probe for my VTVM. Years ago in my shop I did have one, but it was one made for a VTVM, but it wasn't necessarily made for the VTVM I had at the time. Okay, what we're going to do is I'm going to get you a close-up of this meter here, and I'm going to have to see if I can relocate the camera. Hang on. Okay, right now it's off. So let me put it on. Now, from what I understand, I should be able to read 10,000 volts full scale right up here. I'm reading 1, 2, almost 3 divisions. So I'm at 20, 40. I can't even decipher that. I would imagine 20 would be 2,000 volts. Oh, man, this is frustrating. This is why I experiment, and sometimes it takes me days to figure out one little thing because I have to keep trying different things. I don't want to leave this on too long. This electric razor, you see the voltage, how slow it goes down? Maybe the bleeder resistor's burnt out, I don't know, but that's the way it was when I got the bug zapper. I could stick a screwdriver in the grid and it'll snap even after it's turned off. Know what I'm going to do though? I'm going to take the other 10 meg that I've got, the string that I made up. Go on the other side of the shop here, sorry. I'll take this. And we're going to put it across the other 100 meg. This is 100 meg. It's just 10 meg ohm resistors in series. So I'm going to put this one across the eBay one, the blue 100 meg. It'll bring it to 50 meg. You know, resistors in parallel half. And we'll see what we get for a scale on this. Hang on a minute. I'm talking too much. Get this lead out of the way here. Rube Goldberg arrangement here. Let's turn it on. See what we get on the meter. We're reading 20. I don't really know what we're reading here. It's hard to read that. I don't think I can get any closer. Digital zoom, I really don't know if you can see that. And I don't know if it's in focus. We don't want to keep it on too long. It'll overheat that transistor. It's being discharged through the resistor and meter. Alright, well, let's give you the zap test now. Hang on a minute, we'll back this camera off. Okay, here's the two leads. There's the output. This goes to the outer grid. That's why there's a double one here. This goes to the inner grid. Polarity is reversed. This is positive and this is negative. It's just the way they put the diode in here, or the way they just put the wire color coding in, whatever. We got our screwdriver. We're recording. We're going to turn it on. We're going to do two tests. We're going to zap it, and then we're going to let it charge up again, and we're going to zap it again after I turn it off to show you that it will hold a charge. She's on. The LED is lit on the bug whacker supply. All right, we'll turn it off. Power's off. Still holds a charge. Just a little zap, but it did hold a charge. Okay, so that is it, folks. So I've got my work cut out for me. This is what we're working with. Let me back this off here. Hopefully the video is fairly clear. Okay, so that's what I got to do. I really like to use this because it enables me to charge this 3.7 volt battery here up properly. It's very convenient if I can have this jack poked out of the bottom of the handle. But I got to try to cut this off. This is looks like stainless steel, and it's spot welded to the contacts. And the two pins, I don't know if you can see that, the two pins that are in there. So I need to cut that whole assembly off of there very gently, and then I want to transfer that assembly along with this board into the whatever handle I'm going to make, and then combine it with this. So I don't really need to make a voltage doubler. I have no idea what the voltage rating of this capacitor is, because the other bug whacker that I junked from Harbor Freight had a capacitor marked 630 volts but no capacity. It had no capacity rating. Not too worried about the capacity rating. There's too much capacity, it could be hazardous. Of course, this could be hazardous too. Depends, you know, you get zapped on it, it could be quite damaging. Depends on how if you charge this up and you put one hand on here and one hand on the other, if you got a weak heart, it could kill you. But judging from that snap, I don't think I need to make a voltage doubler. And if I did, I would have to put the capacitor and diode on the back of the board. Whereas the other board that I had, it had the extra holes in there that I could put them in, even though they're both Harbor Freight. So I don't know what the rating of this capacitor is. If it's 630 volts, it's not going to stay in good condition too long. It's going to break down. All right. So enough on the high voltage probe at this time. I think what I'm going to do is forget about the high voltage probe right now. I may take some of the suggestions that were given to me for the digital multimeter and try the 1.9 meg shunt resistor across the digital multimeter leads, in addition to the 100 meg resistor that I have, and see how well that works. I figured 10 meg would be good. Also, Andrew, I don't know his screen name, but it was very nice to email me and kind of a complex mathematical equation that he worked out. And he says that my meter's a 1 megohm and not 10. I don't know. I don't understand that. And my meter's loading down that 10 meg that I had across it. The meter could be loading down, but not with 1 megohm. I don't know. I have no way of testing. I have seen on YouTube taking one digital meter, putting it on the ohm scale, and taking the second digital meter and putting it on voltage scale and measure the ohmage of the meter that you're reading the voltage with, And I tried that, and yes, I read about 11 megohms. But anyways, there was a YouTube video on that. So I watch a lot of videos, and as I said before, I'm a tinkerer, so, you know. We tinker. Tinker, tinker, tinker. So this concludes part 2 of the mini snapper. Kind of combined it with the high voltage, but that's okay because it's all related anyways. So I would probably say we're putting out about little over 2,000 volts now that we step this up from 3 volts to 3.7, which is what this battery puts out. And I think that alone will give us a good bug zapper for portable use. Remember, don't be in a hurry for part 3 because I got to figure out what I'm going to put these into the smallest compact handle I can get it into, and I want to try to utilize the charging circuit that's in the electric razor, what's left of the electric razor. Thanks for watching. This is the end of part 2.